Welcome back, my dear students. In this occasion, we're studying problem number 3 from section 1.8 of your geometry textbook, finding the perimeter in a coordinate plane. If we want to find a perimeter in a coordinate plane, we first of all have to find the location of each one of the points given the coordinates. So here, when we found the location of each one of the points, we discovered that the figure that appeared was a triangle. Point E with the coordinates 3 and 6, and point F with the coordinate 3 and -2, and point G with the coordinates -3 and -2. When we trace them all together, we obtain a triangle, and we're asking this problem to find the perimeter of this figure that we have just traced together. Okay, so the first thing we have to do is find the length of each one of the segments. So we have that these two, here we have a segment, here we have another segment, and here we have a segment that in a triangle is called a hypotenuse. Okay, so let's start with the first one, finding the distance or the measure of this segment EF. How do we do that? If you remember, we have already studied how to find the distance of a segment with the formula that is absolute value of the coordinate of E minus the absolute value of the coordinate of F. Okay? We have to think of this as a number, as a line number. Okay? If we think of it as a line number, we're going to see that on this side, the length of this segment is 6 on the positive side. It will be a line number standing vertically instead of horizontally. Okay, and if we think of point of point F, we're gonna see that in the line number, in this vertical line number, it would be standing in -2 right here, -2. Okay, so then we use those same values. So we're going to have then that we're going to have +6 minus F, which in this case is -2. We're going to put that in a parenthesis so we can separate the two minus. In this case, we're going to have, when we solve this, absolute value of 6 minus times minus is going to be positive, because we learned that whenever we have a negative sign or symbol in front of a parenthesis, that changes the sign to positive, right? So then this is going to be now the absolute value of 8, and we know that the absolute value of 8, or the absolute value of any number, is a positive number, which in this case would be 8. So we already found the distance or the measure of the segment EF. Now we need to find the measure of the segment FG, which we want to find the same way we did before, with the coordinates for F minus G, absolute value of the coordinates of F minus G. If we take a look and we use the coordinate plane as a line or a number line, we are going to see that F will have the value, when we're talking about the segment EG, the segment FG right here. Okay, we're going to see that in the number line, F will have the value of 3, because in the number line it will be right here on 3, and G will have the value of -3 right here. Okay, if we use the line number, so if we, on this side it would be 3, and on this side it will be -3. So we put in a parenthesis just as we did before, absolute value. This then will be the absolute value of 3 plus 3, which that is 6, and the absolute value of 6 will then be 6. So we have now both of these values. So now that we have found the value for, let me clean this up a little, the value for this side, or this segment, and this segment, we are needing now to find this segment right here. That is the segment EG, as you can see here. But this one is treated a little differently. Why? Because in a triangle, as you can see, in a triangle, this would be the equivalent of the slope or the hypotenuse. You can see that this is not a this has like a slight bend or inclination, and in this case we are going to use another formula that we learned before, which is the formula for distance. Distance then will be given by the square root of x2 minus x1 square plus added by the value of y2 minus, let me make a correction here, minus y2 elevated to the second power, and then we obtain the square root of all this. Okay, so now let's replace the values. So x2 will be given by, if we take a look at your because we're talking about points E and G, here we're going to have that x1, let's label it so it will be easier. So we have then that we're going to call this one x1, and this would be y1, and then this would be x2 and y2. Okay, so now we're going to see that for our formula, x2 will be 3 minus x1, which is minus 3. We elevate this to the power, plus y2, which in this case is 6, as we can see here, minus y1, which in this case is minus 2 right here. We want to put that in a parenthesis. We close the parenthesis, and then all this elevated to square, and then we're supposed to obtain the square root. Okay, so in this level now we're going to solve. This is going to be 3 plus 3 square plus 6 plus 2 square, and then we're going to have that this is going to be elevated. That'll be 6 plus 8 square, and at the end we are going to have that this is the square root of 36 plus the square root of 64. When we add this together, that is 100. So the square root of 100 is going to be now 10. Okay, so continue practicing, and now you're able to do the homework. See you then in class. Take care. Bye.